All right. Am I here? Yes. Testing sound. Choo-hoo. And okie dokie moki. Where is mm-hmm. Woohoo. Okie dokie. Good afternoon, everyone. Good afternoon for me. It's a beautiful afternoon here in Boston, Massachusetts, East Coast, United States. uh, oof, where am I? What are we doing this afternoon? So, hey, Said, what's up? Andres, yeah, Andres, you're right. I'm going to take you, Andres, I'm going to take you for your word. Now I'm expecting some kind of nice coffee coming my way, just letting you know. Because you were from Colombia, from where? Medellin, Cali, Bogota. Where are you from? I forget. I know you're in Monterrey right now, but anyway, okay. So, all right, what are we doing this afternoon? So this afternoon, so this morning we talked about data structures, we broke down all the terms, and then we saw like grafting and flattening, and then um, and then what else? And then after that, we need to go back to the exercise that we did, where we were trying to make the canopy structure, but we couldn't because of the data problems. All right, just here. I would definitely join you for that one, Said. Now we need to complete the exercise to we need to complete the exercise to now have to now be able to complete the canopy using the grafting and flattening. So that sounds good. And then what are we doing after that? I have here on my list to do data lists. I wonder if that is a little too far. If there's another example that we could do. If there's some other example. I actually did that other example. I think at that point, I wonder if we want to talk about vectors and that kind of stuff. I wonder what we could do that made sense. Huh. I wonder if we could just take a break from data and do data operations, or take a break from data and then do some data operations. And then talk about lists at some point in the future. That could be perhaps a better way to go. Yeah, I have to rethink this. I have to rethink this. So maybe we just do this exercise, and actually we stop here because I need to spend some time rethinking the curriculum. That might be what we're going to do. That might be what we're going to do today. All right. So it's going to be a short stream today in this afternoon because I need to sit down and rethink the plan that I had. I'm not happy with where I was going, how I was going to do. No. Okay. So, all right. So let's get busy then. So this is data tree operations in Grasshopper. And then this is okay. So, and now what I would like to do is introduction to data. And then maybe this should be an exercise. Should be exercise 8, a pavilion. Simple pavilion. I think I'm going to do that. This video is going to be an exercise, and then it's going to be a simple pavilion. It's going to be a simple pavilion. And then the pavilion is going to be, okay, and for that I need to actually create a new, yes, I'm going to save this and I'm going to create a new one. And then it's basically going to be one curve, another curve, and some kind of curve like this. And then the other layer is going to be point, 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 point. Actually, maybe I can just do the exercise that I did. Does this make any difference, really? Actually, I am not going to do that. I'm just going to open the previous exercise we did, which was this one. Okay. Yes. And then and then what I would like to do is, because it's going to be an exercise, I would like to do, I'm going to do it the way we typically do exercises, which is I record the introduction at the end, showing the thing working, but then I will explain the operation here. And I will explain how it was built. And I will start from the build thing in the previous video. Okay. All right, so let's do this. Data. Wait. Oh, no, wait. Sorry. Okay, where were we? Okay, so let's start. So I will record the introduction at the end, and then I'm going to explain that this is coming from the previous exercise that we did. Okay, for this exercise, we're not going to start from scratch because this exercise is actually coming from a previous video that I recorded that should pop up somewhere up there, somewhere, blah, 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 which was about, in which I described the generation of a pavilion where we created two profile curves that were on the ground, sort of, and then we divided those curves into a series of points we joined those points with lines, and then we found some point in the middle or at a controlled relative length. We moved those points a relative distance up in the z direction, and then what we wanted to do in that exercise, in that previous example, was to join each one of these families of points, the first point with the first point with the first point, the second point with the second point with the second point, to create a series of curves that we could use as the profiles for a lofting operation of a surface. Now, in the previous video, which should be popping or should have popped somewhere, or it should be on the description, in the previous video, the problem that we ran into was that we couldn't really create those curves because we had data problems. And that's why in my previous videos in this series, I have also broken down how data is handled inside of a Grasshopper and basic operations that we can do at the data tree level. So for this exercise, I'm going to pick it up where I left it in the previous video. So we're going to be all the way here. And now I'm going to explain how to solve the problem that we had, where instead of all the lines individually, all the curves individually, each one of the arches, we were getting this like continuous the continuous curve that was going through all of this, then going through all of this, and then going through all of these points. Okay? So if you don't know how I made this happen, just make sure to check out the previous video and then come back and join me on this one again. All right. So I'm going to put this here. Why is it? What's going on? Okay. All right. So I'm going to have this here. Okay, and I'm going to switch to this, and here I'm going to open the file. Yes, I'm going to save this. And I'm going to open. Oh, what? I didn't save? Oh, baloney. That sucks. Okay, whatever. Okay, whatever. So this is going to be this. So this is going to be this curve here. This is going to be this other curve here. And what? Oh, because we're probably, yes, because this has to be flipped probably, right? Yes. Okay. And I'm going to save this here. I'm going to save this here. And now I'm just going to save this as exercise. Save as, what exercise is this? Exercise 8. E8. Pavilion canopy. Pavilion surface. Pavilion surface? Now, what is a good name for this? Pavilion. Small freeform pavilion, for example. I guess. I don't know. And then I'm going to save this as E8 freeform pavilion. All right. I'm going to place some bifocals here. Okay. All right. So here. So starting off where we left it in the previous video, I have the two curves that I'm bringing in from Rhino, and then I'm subdividing each one of them into a family of points. I am joining each one of those families of points with straight lines, and then I'm evaluating each one of those lines at a relative parameter across the domain from 0 to 1 in this case, because they're straight lines. And then I'm decomposing the XYZ coordinates. To the Z coordinate, I'm adding a fixed distance, like a height, and then I am reconstructing those points at a distance above that level. And then what I'm doing is I am trying to create an interpolated curve that goes between the first family of points, then the second family of points that I have created, the ones on the top, and then the third family that I have created, which is the ones on the right-hand side. And the problem that I was getting, if I turn everything else off, the problem that I was getting is that as soon as I did that, when I plugged in my three families of points, what I was getting was one single curve that was interpolating through all the points sequentially, one after the other. Okay? And I was not really sure about what the problem was or how to fix that. So now that we know what data structures are and how to manipulate them, we can take a closer look at what's happening here. So the first thing that I'm going to recommend, always, when you have a problem that you suspect might be related to data, then the first thing you probably want to do is to take a look at the data using a panel. So what I'm going to do is I'm going to use this panel and I'm going to plug it into this list of points, the first list of points. And I can see that from a data tree perspective, what I have here is a data tree that has one branch that is called 0, 0, and then it has 15 elements. And this, for the sake of clarity, I'm just going to reduce this to a lower number, like for example, I don't know, 5, something smaller, so that I can see here that I have now 6 points. All right, so that is my first family. And then what I'm going to do also for clarity is that I'm going to copy paste this panel 3 times, and I'm going to compare the first family with the second family and with the third collection of points. What you can see is that from a data tree standpoint, something that is very interesting is that the 3 of them have a very similar structure. The 3 of them are trees that have one branch. The branch has the exact same name, and all of them have the exact same amount of items inside of the list. So that is already giving me an indication of what's going on, okay? But just for the sake of making sure that I understand what's going on, what I'm also going to do is that I'm going to try to mimic, because you see that I'm taking the 3 collect lists and then I'm plugging them into the same input. So what I can't really see is what the data looks as it is going into this component. So what I'm going to do to make sure that I have a better look at that is I'm going to move this here, and then I'm going to drop here a panel, a large one, and I'm going to try to replicate what's happening here at the input. So what I'm going to do is I am going to plug in the first list here, and I'm going to expand this a little bit. Then I'm going to plug in the second one, pressing the shift so that I make sure that I add it together. And you see what has just happened there? Wow, that was interesting. And then I'm going to add the third one, which also gets added right there. That is super interesting because take a look at what's happening here. As soon as I combine the 3 data trees into the same input, what happens is that I stop having 3 different branches with the name 0, 0, 0. I don't have those 3 branches anymore here. Now what I do have is one single data tree where all the elements are in the same branch. And actually, the index numbers, if you notice, they have also changed. The numbers that were from 0 to 5 are now from 0 to 17. So that has been quite a radical change. Why did this happen? Well, it happened because of one of the reasons that I explained before when I was talking about data trees, which is the fact that branch names are unique. So paths are unique, and a data tree cannot have several branches with the same ID. What happens when I combine data inside of the same data tree that had originally data on the same path names, what happens is that Grasshopper takes all the data that was in the same branch and it combines them together into the same branch. So everything that was 0, 0 in the previous data trees now gets combined and consolidated into the same branch, and the index numbers rearrange so that they are sequential one after the other. So this is a default behavior from Grasshopper, and what means is that the data that is going into the interpolate component looks something like this. All right. So that's one thing that is important to note. And then the other thing that is important to note is that one of the biggest rules in Grasshopper is that 95% of the components work at the level of lists. What does that mean? What that means is that if I take wait. Ah. That could have been something interesting to add to the previous video. To show an example of in the previous video, in the one with the data manipulations, to show an example of trying to interpolate over. Oh, that would have been nice. Damn, I really want to do that now. Ooh, that's going to take some rewiring. Oh no. How do we do that? Oh my God. Okay, so, all right, this is going to be complex. So I want to go back to the previous video that I shot, and I want to find a good moment to talk about why operations are important. Man. Yeah, I really need to do that. Okay, let's take a look at the... All right, so we're going to take a break here. Now, actually, you know what I can do? Is I can finish this video as if I was... I can finish this video as if I had that recorded, and then I can refer to that piece and then go back and try to add the new piece to the previous video. Well, that's going to be quite something. Okay, so bear with me. Bear with me. So let me try. Let me then finish this video. Okay. Note to myself. Note to myself. I need to cut in the chunk that I did before. I need to cut right before I started talking about data trees, and then I need to cut and then say, like, as I said in my previous video, data components work at the data level, at the list level. Okay. Okay. Now, the other thing that we need to keep in mind, and it's super important, is that, as I explained in the previous video when I was talking about data tree operations, most components work at the level of lists. And the operations that they do when they take a bunch of data, they do them individually for each one of the lists that is contained of the data tree. What that means is that because the data tree that is coming into this component is one that has this 18 points on the same lists. That is the reason why this component is trying to create one single curve that is going through all the points one after the other. And that is why we are not getting the result that we wanted, which was to have a collection of curves that is going from the first point to the first point to the first point, and then another one from the second point to the second point to the second point, etc., etc. We're not getting that because the structure of the data is not in a way that will generate those different curves. The structure of the data is in a way that the component will only generate one single curve throughout all of these components, throughout all of those points. So what is the solution then? The solution then is that we need to somehow restructure all this data here so that whenever we plug it into the vertices input of the interpolated curve, the data somehow is grouped in one branch for the first point here, the first point here, and the first point here, so that we create one curve through those 3 points. Then we need a second branch that has the second point here, the second point here, and the second point here, so that we create one single curve throughout that list. Another branch with a list that contains the third point, the third point, the third point, the fourth, the fourth, the fourth, so we create individual curves with lists of 3 points. All right? So, if that's the case, what do you think we would do in this case? Would we take these data trees here and would we flatten them or would we graph them? Give it some thought. Give it 1 minute. Pause the video if you need to. All right. So, let's take a look at the options. If we flatten the data, then if we flatten these data trees here, then what we're going to get is actually something that is going to be super similar. It's going to end up being 3 lists with one single list, and then the branch, instead of being 0, 0, is going to be called 0. But we're going to be in the pretty much the same place, because as we combine them, we're going to end up with one branch that is called branch 0, and with all the elements one after the other. However, if we take into consideration, if we think that whenever branch names are the same and we combine data trees that have the same branch names, all the items will go into that branch, then something that we might do is we may want to take a look at grafting each one of these data trees so that we generate one branch per item. So let's take a look at what that could look like. I'm going to graph this tree. So I'm going to graph this one, and I'm going to graph this one, and I'm going to graph this one, and I'm going to plug those in here, and in here. What happens now is that you can see that each item has its own branch that has different names, correct? And then by having different names, what's going to be happening now is that as soon as I combine these new data trees that have so many branches, as soon as I combine them in the same data tree, look at what's going to happen. We have 7 branches here. Now, as I add the second one, pressing Shift, the 2 branches that are 0, 0 combine into one list. The 2 branches that are 0, 0, 1 combine into one list. The 2 branches that are 0, 0, 2 combine into one list. And if I add the third one, pressing Shift, the same thing happens. The 3 branches that are 0, 0, 0, they combine into one list. The 3 branches combine into one list, and the 3. And very nicely now, we have we have the first point combined into one single branch, the second combined into one branch, the third, and we have all the elements on the data tree combined by first, second, third elements of each one of their original individual data trees. As soon as I give this data structure to the interpolate component, look what's going to happen. One single curve is created for each one of the lists or each one of the branches. Again, because most Grasshopper components work at the level of lists. All right? So they operate with all the elements that are contained on the same list. Very rarely they combine elements from different lists or from different branches. It's not how Grasshopper works in this case. All right? Yoo-hoo! So this was a pretty good example of why grafting, for example, can be useful. And it can be useful to do what's called data matching, or in a way, taking data that was in different places and recombining it in a way that is ordered and it matches a particular order. Okay? Wonderful. Sorry, I did a terrible thing. I combined. So let me do this. You typically don't want to go through a panel before plugging things into a component, because whenever you go through a panel, things get turned into text, and only certain things can be reconstructed from text into actual geometry. So let me take that back and plug in the first one, then plug in the second one with the shift, and plug in the third one with the shift. All right. Okay, takeaways. Grafting can be really useful to group things together smartly, especially when you have components that need to operate at the level of lists. Okay? And as usual, please use panels to make sure that what you are doing is that you have a really good sense of what you are doing. The other thing that I would like to do now is just to wrap this up. Remember that this was for some kind of competition visualization. So I have the arches that make the structure of my freeform pavilion, but I kind of want to have something solid. This is not really solid, but something that I can do a rendering with and that I can put some textures on. So I would probably want to create a lofted surface throughout all these arches. So let's go back here, and then it's going to be just as simple as doing freeform, loft, and then place using a loft component across all these curves, except for that this is not working. Whoa, where is my loft? What is happening here? All right, what is going on? Whoa, well, first thing that I need to do whenever something is not going well, let me take a look at what we have. What is going on? I have a data tree with 6 branches, all of them being empty. Oh, that is very strange. Can I place another panel to take a look at what the data that is going into the loft looks like? So the data that is going into the loft component looks something like this. It's a data tree that has 6 branches, and each one of the branches has each one of the curves that corresponded to the data tree that I added before. So I had a tree with lists of points, and now I have the same data tree with one curve for each one of those planes, for each one of those points, for each one of those point collections. So this to me makes sense. But why, whenever I plug this into the loft, I am getting 6 empty nothings, nulls, and I'm not getting the surface that I want? Well, let's think about this again. If you remember, what have I said? 95% of Grasshopper components, they work at the level of a list. They try to operate with all the elements that are on the same list, but they do not combine elements that are on different lists. So now, with that perspective, let's take a look at what's happening here. You see how this data tree is actually a data tree with 6 branches, so 6 lists that contain one single element each. So what the loft component is trying to do is, for each one of these lists, is trying to loft a surface through one single individual curve. What it's not doing is what we intended to, which is to loft a surface through the 6 curves. And it's not doing that because the 6 curves are on different lists. And therefore, it's trying to create 6 surfaces with one curve each. Therefore, that is not a possible solution, and then I get these null results here. Okay, so the data structure that is going into the loft component is not working well for me. I need to change this somehow. The way I need to change this is I need to somehow make sure that all these curves are on the same list, so that I can generate one surface through the 6 curves. And what data tree operation have we seen that removes all the branch complexity, whatever, and leaves all the elements one after the other on the same list? You don't even need to think about this, right? That's going to be flattening a tree. So if I go here and I go to tree and I go to flatten tree, I'm going to try this out. So let me move this a little bit farther away. So I'm going to flatten this tree, and I'm going to, with the panel, make sure that I'm getting what I want. And what I have now is that all my branches are gone and all my curves are on the same data list. And if I plug this in here, now you can see that what I get is the result that I intended, which is one single surface that gets lofted through all the elements on the one single list. All right? And of course, this is parametric, so I can move things around and things will adapt, etc., etc. And I can move this, etc., and all those things. All right? And all right. So that was a freeform pavilion, and that was an exercise where what this exercise was all about was exploring data tree manipulation and why certain times we need to graph data, and why some other times we need to flatten it so that we can keep all the data on the same list and operate. All of this again under the perspective that most Grasshopper components will always work with data that is on the same list, not across different lists on the same data tree. One last word is that I would like you now to see how in my Grasshopper definition, which got a little complex, I have like a bunch of different types of wires actually. I have wires that are a single solid line, I have wires that are a double solid line, and I have other wires that are a kind of dashed sort of double line as well. The only difference between those is that what Grasshopper is telling you is that what the data that is going through for single solid lines is just one single item. So anything that is a single solid line is just going to be one item. Whereas when it's a double solid line, what it means is that it's a data tree that has only one list. So no matter what it is, it's just one single list of data. But as soon as we have the dashed line, what we are seeing is that inside of it, we have a data tree that has multiple branches. So the difference between these three qualities is whether if it's single element, single list, or multiple lists. All right, that's the only thing. Wonderful. So this was Freeform Pavilion just as a vehicle to exploring simple data tree manipulation. All right. I hope this was useful. And again, trust me on this one, 90% of the problems you're going to have are going to be related to data, and then grafting and flattening are going to be super, super helpful always as a first try to see if you can fix those problems. And remember, panels are your best friends here. So always, always, whenever you suspect something might be going on with the data, plug in a panel on the input, plug in a panel on the output, plug a panel, do this exercise of recreating what multiple inputs into the simple panel, what they look like and what data structure they generate, so that you can see and mimic what is happening at the input of your component. It's a really, really useful and helpful operation. All right, wonderful. If you thought this was useful, and if you thought you're liking the work that we do in this channel, maybe you want to consider liking this video, subscribing to the channel, turning on notifications, leaving a gratitude message in the comment, whatever you think is whatever you think we're worth. All right, thank you very much, and see you on the next video of this series, Introduction to Parametric Modeling. Mm-hmm. Okay, now I need to record the introduction. Hi, this is Jose Luis, and welcome to this new hands-on exercise that I am recording for the series Introduction to Parametric Modeling. In this one, I'm going to teach you how to model a free-form pavilion, okay, which is going to be driven by two curves that are in Rhino and that we can move and we can modify just with the control points, etc., etc. But at the same time, there's going to be some parameters, like, for example, how slanted the pavilion is going to be to one side or the other, or how high the central points of this pavilion canopy are going to be from the center. Okay, this is going to be a super simple exercise, but I'm actually using this exercise as a vehicle to explain simple data tree manipulation and two of the main operations that are important in this category, which are flattening data trees and grafting data trees. This exercise is going to be a continuation of a video that I recorded previously, so I won't start from scratch. I will start from like halfway through it, but I will explain anyway what the basics of the exercise are, and but you're welcome to check the previous video if you want to learn a little bit more. Okay. All right, freeform pavilion, data tree manipulation. Let's take a look at what the problem is and how can we solve it. Alrighty, so that was freeform pavilion. All right, I'm going to save this. I'm going to create a new one. No template, no, I need to open data tree operations in Grasshopper. And here, well, I need to first check the recordings because in the recordings, I don't know. Here, what is extremely right, black, in like that, and here there's a bunch. Yeah, so what I'm doing now is that in the previous exercise, in the previous video that I recorded, where I was explaining simple data tree operations, I only explained the operations, but I didn't really explain well, or I didn't give an example of why they could be important. So what I would like to do is I would like to hack into that video and just add like a little clip where I use this, I use the interpolated curve to signify how different the behavior of the component works depending on the structure of the data. And I would like to do that. And so I need to find where I was talking about that and where it makes sense. So this would be flatten the tree as the opposite with actually most common. All right, let's take a look at 1, 2, 3 graph. So 0, 0 for the elements that, and if I use 3 branch, you can see the difference for each one of these elements, and each one of those colors, each one of those items is going to be item number 0. So that is in comparison with flattening, a grafted tree, and this is a flattened inside of Grasshopper. They're like the MVPs, and they're used like all the time. They're so popular. You have us. You can being flattened. I'm pretty old school. Please choose whether. And now I have a small conceptual question that I want to throw here at you, the viewer of this video, or person who is trying to learn algorithmic modeling. If who, give it a few things. You in the data, the whole K in yourself, numbers and paths. Cutting out stuff is always going to be super easy to do. You can afford a lot at first, and if you keep that richness, then it will very likely be useful for you down the road at some point. And again, flattening, then rule of thumb, and it depends always on the case that you are trying to valuable players when it comes to data tree manipulation. And now let's take a look at why is this useful? Why do I even want to manipulate the data tree and do these operations? Now let's circle back to the example that we did a couple of videos ago where we were trying to generate this canopy and we were running into the Entritra, and see you on the next video. Thank you. Bye-bye. You know what? I'm not going to hack the video. What I'm going to do is I'm just going to record a new one. And the new one is going to be... what is it going to be? It's going to be 5.4. 5.4. Yes. It's going to be 5.4 and it's going to be called something new, like list level operations or something like that. So that's going to be list level operations. So I'm just going to do a new video. And so that's going to be, I'm going to save this as list level operations. And here, this one is going to be also list level operations. And I'm going to pause my syncing. Okay. So I'm going to craft, okay. So I'm going to have this data here. I'm going to have this component here. And it's going to be flatten is going to be more useful at this point. And alrighty. Okay, so I'm going to start a new video then. Oh, do I want to do some graphics? Some sucky graphics? Okay, so, all right, so I'm going. So I'm going to save this as save this as 36, and then I'm just going to remove the layers that I don't want from this graphic, and there you go. I'm just going to save this and I'm going to create a new one, and I want to I want to write most grasshopper components operate at the list level. So I want most. I'm going to write most grasshopper. Wow, what is going on? This looks really bad. Most grasshopper components work the work at, and then here it's graffiti time. I wonder, can I do something like, no. Work at list level. Well, that's kind of nice, actually. Well, that's not terrible. It's much better than my own. It's much better than my handmade graffiti. All right. So that was all right. So what am I going to do now? I'm going to start the video and I'm going to say that instead of going to right on into the exercise, I want to explain a concept. All right. Hi, this is Jose Luis, and in my previous video on this series, Intro to Parametric Modeling, I gave you the two most basic operations that we can do with data trees, which are grafting and flattening. And I said that I was going to give you an example of how to do that. But before we do that, I actually want to explain a super important concept that justifies a lot of why these operations at the data tree level make sense. And it is the fact that as a general rule of thumb, 95%, I don't even know how many of them, but like most grasshopper components, the way they work is that they perform their operations at the list level. Ta-da! And I'm flashing this like really red because it's super important to understand. Most grasshopper components work at the list level. What does that mean? What that means is that the operations that they do with all the elements that are part of the same data list, so a part of the same branch or the same list, but they will very likely not combine elements that are on different lists or different branches. Only a handful of components that work at the tree level do that. So, but what does that mean actually? Well, let's go back to the example that we had where we had the surface and we subdivided it into a collection of points in 3D. And remember how we, by default, we had this tree with 3 branches and 5 elements on it. And then if we flattened that tree, then what they ended up getting was this one list of points, one after the other. Or if we graphed them, what we ended up getting was a data tree where each point was in its own branch or in its own list. Okay? Well, then let's take a look at why this makes any sense. So what I'm going to do is, just for the sake of visualization, so that it's easier to see things, I'm going to click here and I'm going to type hide to remove the view of the surface from the Rhino viewport. And I'm also going to temporarily hide this point visualization by typing Ctrl Q. What I'm going to do now is I'm going to say, what would it happen if I tried to create an interpolated curve through all the points that are coming out from this component and which have this data structure here. So let's take a look at what would happen. If I go to curve and I go to spline and I go into interpolate, this component is going to try to create a curve that passes through a collection of points. If I do that, and if I place this here, let's take a very close look at what's going to happen. So what is going to happen is that as soon as I plug this in here, what I see is that the result is that I am getting 3 independent curves. But I thought I had 15 points. Why am I not going through all of them? Well, it turns out that if I now look at the structure of the data that is coming out, the structure of the data that is coming out matches the structure of the data that was coming in, which is 3 branches, 0, 0, 0, 1, 0, 2, and each one of them with a curve. This is because the interpolate component is canonical in the sense that what it does is it tries to create a interpolated curve through all the points that are contained on the same branch. And because the data tree that I gave it has 3 branches or 3 lists, then what it tries to do is one curve through all these points, another curve through all these points, and a third curve through all those points. And the resulting data tree structure looks the same as the input one. All right? This literally is the main reason why data tree structures make sense, because those groupings are really helpful to control the behavior of the form generation and the geometry generation of many components down the road. Now, let's take a look at what would happen if instead of plugging in creating interpolated curve from the points as they come out of the component with this particular data tree, I would do it from the flattened tree. So let's take a look at that. I'm going to plug in here. And now what we see is that the interpolate component is trying to create one single curve through all the points, the 15 points that I have in my list. And that is because the structure that of the data that I gave it is just one single list with 15 points, one after the other. And then the resulting outcome is 0, is one curve at the branch 0. The same structure as the incoming branch. Does it make sense? Again, because interpolate, just like every other component, works with the data at the list level. Everything's on the same list. That's what it tries to create a curve with. So now, can you imagine what is going to happen as soon as I try to plug this into the grafted data? Take a minute to think about it. Pause the video if you need to. I'm about to do it. I'm going to do it. I'm going to do it. What do you think is going to happen? Bam! Disappointment. So what's going to happen is that because the structure of the data that was coming in is one single point per branch, when the interpolate component tries to create a curve through one single point, that is not enough data to create a curve. So what ends up happening is that the component creates a tree that has the same structure, but inside of each branch, there is a null element because the operation that it generated was invalid. The interpolate component cannot create a curve through one single point. All right? Wonderful. This that you just saw here is the gist of why data manipulation and data trees make sense for example, in Grasshopper, in the case of this particular way of working with data trees in terms of algorithmic modeling. Now, I think, and again, long story short, and what I would like you to tattoo on your arm if you need to do, is that most Grasshopper components work at the list level, and they only operate with all the elements that are on the same list. Okay? So, what do we do now? Well, I think we are now actually ready to go back to the Freeform Pavilion example that we did a little bit and try to figure out now what the problem was and how can we use data tree manipulation to solve that problem and to create the Pavilion canopy. Thank you very much. Don't forget to like this video and subscribe if that's what you feel you want to do. And see you on the next video, and let's get a little bit hands-on. Bye. Alrighty. Okay, so I think with that, I'm going to leave it here because I now need to sit down and think, what are we doing for the next videos? So I need to plan a little bit ahead. And I have a meeting this afternoon as well. Um, yes. So yeah, any questions? It would be interesting to make some examples of the path mapper. That is a really good point, Salvador. I think I have that on my curriculum, but I think that's a bit more of an advanced topic. So I will leave that for the end of the playlist. But you're absolutely right. Path mapper is one of my favorite components, actually. It's very versatile, very useful, very, very nice. Salvador, what could be a good exercise that would justify needing to use path mapper? Oh, think about it from a teaching perspective, from an educational perspective. Find what is the good problem that needs to be solved or could only be solved, or is the best way to solve it is by using the path mapper. Give it some thought. And if you find one, let me know, because I will be more than happy to broadcast that. All right. Okay, well, with that, I'm going to stop here. Just a friendly reminder, I will be recording tomorrow, but I will not be recording in the morning because I have meetings in the morning. So I will start at 2 p.m. in the afternoon. Okay. So, but as usual, just subscribe to, follow us on our social media to know when we are going live. Join our Discord server to get updates on where we're going live, and also you can follow our Google Calendar. You can subscribe to our Google Calendar to get more news, more information about the events of when do we go live. Okay. Is there a possibility to flatten part of the branches instead of the entire list through some parameters, or should it be done manually? Well, the way I would do that, Nylon, is I would take the data tree, I would extract the branches that you want to flatten them, and then recompose, add that branch back into the original data tree from which you extracted those branches. That's how I would do it. But that's also a bit more of an advanced operation that we're not going to see on this. We're not going to see anytime soon on this playlist. Okay. Well, thanks a lot. Thanks everyone. Bye bye. Have a good one. See you tomorrow. Tomorrow in the afternoon. No morning session. Okay. Blah blah. Bye bye.